In this video, we're going to take a look at other types of visual displays, other types of graphs, as well as some qualities and characteristics that could make a graph misleading. So for the first part of this video, we're going to look at scatter plots, line graphs, and time series graph, and just give a quick overview of what each one of them is and what they're used for. So scatter plots, which we'll talk about in more depth in a future video, is a visual display which can be used to examine an association between two variables. So, for instance, here I have weekly hours studying and then exam score. So, in this case, taking a sample, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, probably about 15 or so observations and plotting their how many hours they studied each week compared to what their exam score happens to be. We can use a scatter plot to see if there's an association between the variable number of hours studying and the variable exam score. And again, we'll talk about scatter plots in more depth in a future video. We also have a line graph, which is similar to a scatter plot. However, the points are connected in the order that they're obtained. So here we have some sort of a treatment. Maybe it's a medical treatment and a response time in milliseconds or in seconds. So this might be a psychological experiment or a medical experiment. Who knows? But we plot each one of the values. In this case, the first treatment, the response time looked to be about 9 seconds, whereas maybe before treatment started, the response time was 12 seconds, and we can see this downward pattern as we increase the treatment numbers and the response time. So we connect these points in the order in which we obtain them. So keep in mind, we could have done the same idea with a scatter plot, but it would look really crazy with all the lines zigzagging all over the place, and we don't usually do that with scatter plots, but we do in fact do that with line graphs. Related to a line graph is a time series graph in which it shows changes over a specific period of time. So here we're looking at a very common time series graph, which is stock price. So here we have the x-axis, the horizontal axis represents the nth day of trading. So first day, second day, third, fourth, etc., all the way up to 23rd day of trading, and then the stock price. So it appears that before we opened up the trade on the first day, the stock price was about maybe $32 a share. It dipped down the first day and then rose back up to maybe about $33 or so a share the second day, and it increased and decreased as time went on. So if we're looking at how a value changes over time, a time series graph is perfect for that. All right, our second part of this video, we're going to look at qualities of misleading graphs. And at the end of the video, I'll give you a very good resource if you want to learn more about visual displays of data, both misleading and non-misleading. So some visual displays, whether they're intentional or not, can be misleading, and we can't automatically assume that the person who created the visual display had ill intentions in trying to mislead us with their display, but unbeknownst to them, or maybe beknownst to them, their visual display can be misleading. So here are some things to watch out for, which we'll talk about in the rest of this video, but by no means is the following list exhaustive of everything that you could possibly be on the watch out for. So the first is the vertical axis not starting at 0. We'll take a look at an example of how that misleads the reader into maybe forming a conclusion from it that may not really be valid. The use of 3 dimensions, we'll have an example of that. It's very common with bar graphs with things like spreadsheet software. So in fact, the example I have for you is actually from a spreadsheet program. So also a disproportionate use of area. So especially common with like picture graphs and things where if we change one, like a measurement, like a length, that doesn't mean that the area changes by that same amount. There's some geometric properties with ratios of areas and lengths and things like that that may be unintentionally misleading in terms of their use in print and on screen. So for the vertical axis and 0, sometimes our data can be misleading because the vertical axis not beginning at 0 can be misleading. So here we have a bar graph below in which Smith received 53 votes and Jones received 42 votes. So obviously Smith won, but notice that the vertical axis does not start at 0, it starts at 40. Now we could have it go down to 0 with a break in the graph, but here it's starting at 40 instead of 0. And if we look at the sizes or the heights of the bars, it appears as if we just look at the bar height alone, it appears as if Smith is maybe about received about 4 or 5 times the amount of votes than Jones did. So depending on where our vertical axis starts, we can really make it look like Smith absolutely destroyed Jones in this election, even though Smith only won by a raw total of 11 votes. But it definitely looks like Smith really just absolutely destroyed Jones in this election if we look at the heights of the bars. So if we were to fix this and have the same scale, so we're still counting by fives, like 40 to 45, 45 to 50, still counting by fives. We can keep the same scale if we want, but now if we start at 0, now yes, Smith still did win, but it doesn't look like it's 4 or 5 times the amount of votes that Jones got. So again, make sure when you're graphing bar graphs, histograms, and the like, try to keep your vertical axis starting at 0, because otherwise you could really mislead the reader into drawing false conclusions. So the use of 3 dimensions for bar graphs and histograms can result in data appearing slightly larger in frequency or relative frequency than it should. Pie graphs isn't exactly a major issue using 3 dimensions, but if we take a look at the following for the same vote count, here with the 3rd dimension of depth, it appears as if Smith, let's see what Smith had again. 53 and 42. So looking at this height, it's below the 50 line. This one is slightly above the 50 line. It's a little bit deceiving as far as how can we best judge the difference in votes between Smith and Jones unless the heights of each of these prisms were labeled. So again, try to avoid using 3 dimensions for bar graphs. I've seen it in presentations, and even though it has a 0 bottom for the vertical axis, I still don't like it when I see vertical or 3-dimensional bar graphs because of the misleading nature that they bring. So here if we use, again, keeping in mind that Smith received 53 votes and Jones received 42 votes, if we use bubbles or circles to represent the number of votes each candidate received, and let the radius be the number of votes they got divided by 10, just so it's easier to draw. So if we draw a circle where Smith's radius is 5.3 centimeters and Jones' radius is 42 divided by 10 is 4.2 centimeters, taking a look at these 2 circles, because of how we calculate area, it appears as if Smith received a significantly higher number of votes than Jones did, even though the difference in their radii is proportional to their difference in their votes. The areas of these circles are not proportional to the 53 votes for Smith and the 42 votes for Jones. So, all right. So, for more information on visual displays of data, whether they be different types of visual displays we've talked about in the past couple videos, or misleading visual displays as well, I strongly urge you to check out the book, The Visual Display of Quantitative Information by Edward R. Tufte. This is the second edition. It's the latest edition as of this recording, so it's a fairly old book by textbook standards, although it's really not a textbook. This is actually a picture I took of my copy, so I can actually see the tape that I used to tape my cover down, the dust jacket down. But this is the standard in terms of visual displays of information. He also has a couple other books out as part of a series here, but this is a very famous book that'll give you a lot more information than I did regarding displays of data. So if that's something that you're interested in, I strongly urge you to maybe head down to your local library and check it out, and hopefully you can gain a lot from the book. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.